Okay, so today we will discuss dispersion of light. We had discussed about this topic in class 10. There we had studied that how a ray of light, when it passes through a prism, we get different colors. That means the white light gets split into 7 components. We term it as VIBGYOR, which we call as a spectrum of white light. Now, those things we are going to study here, but we are also going to study a very important question, like why different colors are having different deviation from its path. Okay, those things we are going to discuss it here. Now, to understand this, let us just understand these two figures. So in this figure one, first figure, says the blue shade is my medium 1 and the black shade is my medium 2. Okay, and blue shade, let us assume that he is rarer, and the black shade, let us assume that he is denser. This dashed line is the normal perpendicular to this interface, which is separating the mediums, medium 1 and medium 2. So if we allow light in this direction, so since he is moving from rarer to denser, so he bends towards the normal, which he gets deviated from its original path. Okay, but if we increase the refractive index of this medium more, like if we increase it more, then this path will be deviating more towards the normal. So it depends on the refractive index value, what is the medium. Okay, based on that refractive index value, he gets deviated from its path. Understood? So let's come back to this figure. Here also, the similar two mediums we have considered. He's rarer and he is denser. But here we had considered white light. As we know that white light is composing of all the different color wavelengths. So we consider this white light and we allow him to fall on this interface. Now when this white light is moving from this medium 1 to medium 2, something phenomenal thing happens. And that is all the colors, all the different wavelength value get splitted and all the colors have different angle of deviation. Yes, we can see that violet is deviated the most, red is deviated the least. Okay, so why this is so? Why violet is deviated the most and why red is deviated the least? Okay, but this fact, you have to keep this in your mind, that when a white light is moving from one medium to another, and while going through refraction, he splits, the white light gets split into its 7 components, and all those separations takes place at different angles. Okay, violet is deviated the most, and red is deviated the least. Okay, so you can just pause this video and you can just take a note of all this. The deviation suffered by the violet color is maximum and the red color is minimum. Okay. Yes. So why this dispersion happens? Basically, is this equation? This is called Cauchy's equation. Okay. Cauchy's equation, CAUCHY. Now Cauchy derived a relationship between refractive index and wavelength of the color. Okay, refractive index of the material and the wavelength of the color. For example, if I ask that what is the refractive index of water, so it is very common answer that the refractive index of water is 1.33. But if we talk about what is the refractive index of water for red color, so the refractive index for water for red color, it is 1.33. Okay, but for blue, the answer is a little close. For blue, the refractive index of water is 1.34. Okay, so for different colors, we have different refractive index values. So how we can find a relation between them? So Cauchy has derived a relation which actually tells what is the connection between refractive index and wavelength of the color. Here you see this A, B, C, these are nothing but your constant. Okay. Now, so since we can clearly see that refractive index is inversely proportional to wavelength value from this equation. Okay. So when we talk about all the colors which white light is composing of, no? So white light is composed of all the colors: violet, indigo, blue, green, yellow, orange, red. So violet is having the least wavelength value, and red is having the most wavelength value. Okay, we know this fact that wavelength for the red color is way greater than the wavelength for the blue color. Sorry, violet color. Now, since wavelength for violet is very less, so that's why refractive index for violet is very more. We can see very clearly from this relation. And since wavelength for red is more, so refractive index for red is very less. Okay. So we have clearly mentioned that since wavelength for violet is smaller than the red light for the formula, so it follows the refractive index for the material for violet is more than the refractive index of the red color. So we have seen this relation. Okay. All right. Now from again small angle prism. Now this relation, you just keep this in your mind. Okay, we don't need the derivation of this relation. Okay, this small angle relation. Even though we know the factors of this, what do I say? What is this del and what is this a? We know the terminology of these terms, but there is a separate derivation where how you can find this relation. We don't need that, but for time being, you just keep it in your mind that we have a relation for small angle prism. Okay, so small angle prism, we have this relation del equals to a mu minus 1. So when we use this relation, okay, so we can clearly see that angle of deviation is directly proportional to my refractive index value. Okay, so since from this relation we have seen that violet refractive index value is way greater than refractive index of red. So that's why from this relation we can derive that angle of deviation for violet is way greater than angle of deviation for red. Okay, so that's why violet is deviated the most, red is deviated the least. Okay, so from board point of view also, this has been asked many times that why violet color suffers greater deviation than red color when it passes through any prism. So you have to mention this Cauchy's relation, and you have to express that how refractive index is inversely proportional to the wavelength of the colors. Okay, you have to clearly mention that the violet wavelength is smaller than the red, hence refractive index for violet is more than the refractive index of the red. And using the small angle prism, this relation, you can actually tell that deviation for violet is greater than the deviation than the, okay.